An installation is in violation of the National Electrical Code because of an improper instantaneous strip circuit breaker setting relative to the motor's full load current and a potential gap in protection with the overload relay. National Electrical Code 430.52 C3, exception number 1, dictates that the maximum trip setting of an instantaneous trip circuit breaker should not exceed 1300% of the motor's full load current. Even a motor with a full load current of 34.8 amps, the maximum allowable trip setting would be 1300% multiplied by 34.8 amps, which equals 452.4 amps. The circuit breaker is set to 520 amps, exceeding the code-compliant limit. There's a protection gap because the overload relay has a self-protection limit of 298 amps, while the circuit breaker's minimum trip current is 390 amps. In a high-impedance fault scenario where the current falls between these values, the overload relay could be damaged without the circuit breaker tripping. This poses a safety hazard potentially leading to fire or other dangerous situations. To rectify this National Electrical Code violation, the instantaneous trip circuit breaker setting must be adjusted to comply with the 1300% limit based on the motor's full load current. Also, installing a ground fault protection device can safeguard the motor against high impedance fault conditions. Let's delve deeper into the components and calculations involved. The motor in question is a 30 horsepower, 460 volts, 3-phase induction tight square cage non-design B energy efficient motor. It's protected by a combination motor controller including class 20 melting alloy type overload relays, 1 per phase, and National Electrical Manufacturers Association size 3 non-reversing starter, and a 100 amp adjustable, instantaneous strip circuit breaker. The motor has a locked rotor indicating code letter of J as per National Electrical Code Table 430.7. B. The overload relay is sized for a motor with a full load current of 34.8 to 37.3 amps. The time current characteristics extend to 8 times the trip rating, approximately 298 amps, which represents the overload relay's self-protection limit. The instantaneous strip circuit breaker is set to 1300%, resulting in 520 amps, aiming to prevent nuisance tripping during motor starts, according to National Electrical Code 430.52. C3 exception number 1. However, considering a plus or minus 25% pickup tolerance, the breaker could trip as low as 390 amps. The potential problem arises from the gap between the overload relay's self-protection limit of 298 amps and the circuit breaker's minimum trip current of 390 amps. If a high impedance fault occurs, producing a current between these values, the overload relay could be damaged without tripping the circuit breaker. The main concern here is that the circuit breaker's setting exceeds the allowable limit as calculated from the motor's full load current. We're calculating the maximum allowable setting. We use the 34.8 amps full load current and multiply it by 1300%, or 13, resulting in 452.4 amps. The breaker is set to 520 amps, which is higher than permitted. This discrepancy violates the National Electrical Code. The gap between the overload relay and the circuit breaker settings presents a hazard. If a high impedance fault limits the current to a value between 298 amps and 390 amps, the overload relay may fail without the circuit breaker providing protection. A high impedance fault is a fault where the fault current is limited, often due to poor contact or insulation breakdown. It can cause overheating and arcing, posing a fire risk. Ground fault protection devices detect current imbalances between the phases and ground, tripping the circuit to prevent damage and hazards. They are particularly effective in detecting high impedance faults. To correct this situation, firstly, the instantaneous trip circuit breaker needs to be reset to comply with the National Electrical Code requirements. The setting must not exceed 1300% of the motor's full load current, which translates to 452.4 amps. Secondly, consider installing ground fault protection. This will provide additional protection against high impedance faults that might not be detected by the overloads or the instantaneous strip breaker alone. Let's further analyze the National Electrical Code sections relevant to the scenario. National Electrical Code 430 covers motors, motor circuits, and controllers. Specifically, Section 430.52 addresses motor circuit short circuit and ground fault protection. National Electrical Code 430.52 C deals with instantaneous trip circuit breakers. Exception number 1 allows the instantaneous trip circuit breaker to be used without an instantaneous trip, provided it's part of a listed combination motor controller having coordinated protection in the motor starter. However, the setting limitations still apply. National Electrical Code Table 430.7 B provides the locked rotor indicating code letters for motors, which is used to determine the appropriate short circuit protection. In this case, the motor has a code letter J. National Electrical Code Article 100 defines terms used in the code, including motor full load current. This value is critical for calculating the maximum allowable setting for the instantaneous strip circuit breaker. The motor controller components also play a vital role. The Class 20 overload relay is designed to trip within a specific time when subjected to an overload current. The relay's time current characteristics define its response to different levels of overcurrent. The National Electrical Manufacturers Association Size 3 non-reversing starter is used to start and stop the motor. It includes the overload relay and other control components. The instantaneous trip circuit breaker provides short circuit and ground fault protection. It's designed to trip very quickly when a high fault current is detected. In summary, the situation described presents a National Electrical Code violation due to the circuit breaker setting exceeding the allowable limit. It also poses a safety concern due to the potential gap in protection between the overload relay and the circuit breaker. Corrective actions include adjusting the circuit breaker setting and adding ground fault protection. By adhering to the National Electrical Code and implementing appropriate protection measures, the safety and reliability of the motor and electrical system can be ensured. Consider the implications if the motor was a Design B motor instead of a non-Design B motor. Design B motors typically have lower inrush currents compared to other designs. This difference in inrush current would affect the selection and setting of the instantaneous strip circuit breaker. Since Design B motors have lower inrush currents, the instantaneous trip circuit breaker might not need to be set as high to avoid nuisance tripping during motor starting. This could potentially reduce the gap between the overload relay self-protection limit and the circuit breaker's minimum trip current. However, it is still crucial to verify that the circuit breaker setting complies with National Electrical Code 430.52. C. Exception number 1. And to ensure that the circuit breaker provides adequate short circuit and ground fault protection for the motor. If the motor had a different locked rotor indicating code letter, the selection of the short circuit and ground fault protective device would be affected. National Electrical Code Table 430.7 B provides guidance on the maximum rating or setting of the short circuit and ground fault protective device based on the motor's locked rotor current. A different code letter would correspond to a different range of locked rotor current, which in turn would influence the maximum allowable setting for the circuit breaker or fuses. It is essential to consult National Electrical Code Table 430.52 and the motor's nameplate to determine the appropriate protection for the specific motor. Let's discuss the role of the combination motor controller in this situation. A combination motor controller integrates the motor starter, overload protection, short circuit protection, and disconnecting means into a single unit. This provides coordinated protection for the motor and simplifies installation. In this case, the combination motor controller includes a National Electrical Manufacturers Association Size 3 non-reversing starter, Class 20 overload relays, and a 100 amp adjustable, instantaneous trip circuit breaker. The combination motor controller should be listed and labeled, indicating that it has been tested and certified to meet applicable safety standards. The listing typically includes information on the controller's short circuit current rating C/R, which is the maximum fault current that the controller can safely withstand. It's vital to verify that the available fault current at the installation location does not exceed the controller's S/C/R. Also, Note that the 100 amp rating of the instantaneous trip circuit breaker refers to the breaker's continuous current carrying capacity. The adjustable trip setting allows you to adjust the current level at which the breaker will trip instantaneously in response to a short circuit or ground fault. The 1300% setting refers to the maximum allowable instantaneous trip setting as a percentage of the motor's full load current. For a motor with a full load current of 34.8 amps, the maximum instantaneous trip setting would be 452.4 amps.